AOPS following one the basics, number 26. Which are true? Z plus 3i's conjugate is equal to z minus 3i. I times z to the conjugate is equal to negative I times z conjugate. Or 2 plus I squared is equal to the conjugate of 3 minus 4i. Right off the bat, we can apply our knowledge of the conjugate for any complex number, represented by z1. So let's set z1 to be equal to a plus bi, where a is a real term and bi is an imaginary term. So the conjugate of z1 will be equal to a minus bi. And the definition of the conjugate is to take the opposite symbol for the imaginary term. So if the imaginary term in this case is positive, becomes negative. If it's negative, becomes positive. So right off the bat, we see here that the conjugate of z plus 3i must be equal to, according to our definition, z minus 3i, the same thing right here. Therefore, this first expression is correct. And what about the second expression? Well, remember the definition of the conjugate, I times z. In this case, our real term is 0. This can be rewritten as 0 plus iz. And 0 plus iz still correlates with our definition of the conjugate right here. So the conjugate of this expression, all we have to do is change the symbol in front of the imaginary term, which is iz, which is equal to negative I times z's conjugate. So the second term follows out as well. And what about the third and final expression? Well, to find it out, we can first evaluate this conjugate on the right-hand side. 3 minus 4i's conjugate is equal to 3 plus 4i. And what about 2 plus I squared? 2 plus I squared is equal to 4 plus 4i minus 1, which is equal to 3 plus 4i as well. We see here that the two expressions are congruent, therefore the third expression checks out as well, meaning that all three expressions are true.